We have a few more of these domain problems to work through. We're now on exercise 9. Find the domain of this function, x over the square root of 4 minus x. And so while there's a few different things that can happen, I think we can sum up the kind of trouble that we're looking for. Comes in two forms. Either there's an x in the denominator, or we have a square root involved, and so we got to be careful to make sure we're not trying to take square root of a negative. In this problem, we have x in the denominator, and we have a square root, and they both occur down below, right, in the same spot. So sometimes this problem's a little bit confusing because the denominator and the square root problem are in the same place, sort of. I just want to go back and, while this occurs to me, make a comment about exercise 7 that we already went through, if you've been watching through these. You know, the numerator is never trouble. So we had the x squared minus 6x, or minus x minus 6 in number 7. That trinomial was just fine. We just sort of, it was no problem for the denominator. Only the denominator caused trouble. So just to compare to this problem, this x up above is perfectly fine in the numerator. We don't, no trouble at all. Okay, we just look inside square roots and we look in the denominators. So let's maybe first look at the square root trouble. So inside the square root, we got 4 minus x. That's got to be greater than or equal to 0. Now I can just add x to both sides here to say 4 is greater than or equal to x. But now you need to know how to interpret this inequality. Even though the greater than or equal to sign is here, this is referring to a portion of the number line that is to the left of 4. Right? Because while 4 is greater than or equal to x, the x values that satisfy this are values of x over here, smaller than 4. The x values themselves are not greater than or equal to 4. You can always turn around the inequality. If it's helpful for you, an inequality like this can always be written with the variable on the left-hand side. And if you turn the inequality around, the inequality sign turns around also. So that's the same as saying x is less than or equal to 4. So sometimes writing the inequality with the variable on the left, just turning it around, makes it a little easier to read. Either case, this is the meaning. All right. Now that's as far as the square root's concerned. But now we have this second issue about the denominator. And so this issue of, even though it's a complicated mess, can that denominator ever be equal to 0? And what we can do is square both sides, and we get 4 minus x equals 0. Solve for x. 4 is equal to x. This must be removed, because when x is equal to 4, while the square root doesn't mind, the denominator minds, we'd be dividing by 0. So the denominator issue is kind of hidden in there inside this square root. Here we have to actually remove the closed circle. We have to put in an open circle. At 4 because of the denominator issue. And so the domain, the the final domain answer for this problem is going to be all real numbers less than 4, with 4 not included. So we're going to go from negative infinity to 4 with a parenthesis, not a square bracket. Again, the square root would allow us to leave a square bracket, but because of the denominator issue, we have to throw out the 4. And the final domain is that interval. Okay, we got 2 more to do here. And I like these 2 because they don't, there isn't much to write down, but it's more like interpretation of notation. Fractional exponents occur in a lot of applications. So you should know how to interpret a function like f of x equals x to the 3/2. You should know that the denominator of the exponent refers to a root, in this case a square root. So f of x here is equal to the square root of x. The numerator exponent refers to a power cubed. Or you can also write it as x cubed square root. Either way, they're the same. And I think I need to think about this interpretation to see what I have to worry about as far as the trouble is concerned. Well, there's no x in the denominator. The trouble is I have a square root. And I have to look at what's inside the square root, which is just x, and x has to be greater than or equal to 0 for this expression to be defined. There's no denominator to worry about. This is the only condition on the domain. So the domain, once I realize that, is going to be square bracket 0, comma, infinity, all real numbers greater than or equal to 0. So when you write x to the 3/2, you need to be aware there's a square root involved there. Now exercise 11 is kind of similar and with a couple variations. It's not 3/2, it's 2/3 as an exponent. And I also added a complication. I threw in a minus sign on the exponent. So you know when you see a negative exponent like that, it means 1 over x to the positive 2/3. And so here, if I convert to root an exponent, that's 1 over, that's a cube root of x. That 3 in the denominator means cube root. And then we're squaring. Or you could also write that as 1 over x squared inside a cube root sign. Those are, again, the same. They're equivalent. And so the trouble is here, there's no square root. The trouble is x in the denominator. That's the trouble. Cube root is no trouble for domains. We like cube roots for domains. In fact, the cube root function we graphed in our toolkit, its domain is all real numbers. So cube roots of all numbers is defined. So it's a little uglier to write down, but it's actually easier to deal with as far as domains are concerned. So here we just have to see when is the denominator equal to 0. So when is the cube root of x squared equal to 0? And the only way that can happen is, the cube root of x would have to be 0. That's the only way the square of that could be 0. And if you cube both sides, The only way that can happen is x is equal to 0. So once you realize that, the domain here is all real numbers except 0. So in one way to just see that is 0 is the only number you could plug into this function to get division by 0. There's no other number that would cause denominator 0. And we've already written that down in interval notation, so let's just go ahead and write that again. So this is like the real number line with a hole at 0, so we got to express it in two pieces, negative infinity to 0, union 0 to infinity. And there's our interval notation answer for exercise 11. So 10 and 11 look kind of similar, but notice the trouble is very different. Trouble in number 10 was the square root. Trouble in number 11 was x in the denominator. Cube root was no trouble at all.